Good morning, everyone. Welcome to all to the GCP Data Engineering course. So let us start the session for today. So yesterday I have given you overview regarding what is actually the data engineering, and after that the Google Cloud Platform, and we have discussed about the course content as well, right? So I'm going to take up the class further. So let us start the session. So for next 5 to 7 days, we are going to learn about the Google Cloud Platform. So for example, we're going to be starting with what is actually the cloud and why we need the cloud platforms. Okay. And after that, the difference between the on-premises versus cloud, and then only you'll be able to appreciate the technology of the cloud compared to the on-premises. And after that, I'm going to again describe what is the Google Cloud Platform and why we need to learn the Google Cloud Platform and how are the opportunities for the Google Cloud Platform and the service overview, GCP interfaces. We're going to be learning the interfaces one by one so that we will be able to interact with each and every service via these interfaces only. So that is console, shell, and cloud SDK, console walkthrough. After that, we're going to be learning about the GCP locations concept such as regions and zones and the importance of the regions and zones while we are deploying an application, and the importance of the IAM and admin, identities, roles, resource hierarchy, the importance of the resource hierarchy and roles, and the networking basics such as VPC, firewalls, and load balancing. Okay, so these are the concepts that we are going to see for the next 5 to 7 days, and then we are going to be starting with one of our first service, that is Google Cloud Platform. Right, so these are the services that we are going to learn. Once we have completed our GCP basics, we're going to be starting with these services one by one. Okay, so let me start with, sorry. I think we are good, right? Yeah. Hope you all can hear me. Yeah, your voice is breaking, so that's the reason I couldn't hear you properly. Okay. Okay, can anyone confirm that you guys can hear me clearly?
Yeah, we can hear you.
Great. Oh, my screen is not visible.
It's visible.
Can you raise hand who can't see the screen? Okay, wait a minute. I think here it stopped. Okay, great. So let us start the session. So before entering into the Google Cloud Platform, let us try to understand why we need a cloud platforms. Why we need the cloud platforms and what was the culture before the cloud platforms, so that how people used to work or how people still working. So let us try to understand. Okay, take for example, usually what happens in the companies or what happens in the organizations is that, so there will be an organization will be there, and in each organization there will be a plenty of the departments will be there. Each department will have a plenty of projects will be there. Each project there will be a one requirement. Okay, so there will be a business people who comes up with a requirement. So they wanted to, for example, assume that they wanted to build an application. Okay, a application for the users they wanted to build. So for that one, business comes up with a requirement saying that we need to build an application. And after that, a business analyst or a business analyst coming to the picture, he will gather all the information. He will gather all the information required or needed to the he needed to analyze the business, and he will convert that high level information into a set of proper information, and he will pass on that information to the solution architect. What the business analyst will do, he will the business comes up with a requirement for the application. The business analyst gather the needs from the business, and he analyzes it and converts it into a set of high level technical requirements. Then he will pass that information to the solution architect. Okay, now the solution architect, what he will do, the solution architect will design the architecture to be followed for the deployment of this application. What he will do, sir, he will prepare an architecture for the deployment of this particular application, and that architecture will help you to how to build an entire application from the scratch. Okay, so that is what the solution architect will do. And solution architect not only creates a design architecture, he will also think that whether we have the required resources available in company or not. What he will do, he will also not only he will be preparing the technical architecture to be followed for the deployment of the application, and he will also make sure that he will be having all the infrastructure such as servers needed for the front end web server, or the backend server databases, or the load balancers. So he will make sure that all of those things are available. If those things are not available in the house, he will try to, or in the house means in the organization, he try to put a request to the procurement team. Okay, so this is how the company is treated. So a business comes up with a requirement, and business analyst gathers all the information, and he will pass on the technical, high level technical information to the solution architect. Solution architect will come up with a design architecture, and he will also make sure that everything is available for the deployment of the application. All the resources are available in the house for the deployment of the application. If those resources are not available, what he will do is that he will put a request to the procurement team. What the procurement team is do is that he will try to create a ticket to the vendors team, and the vendors team vendors team get all those resources, and they will be moving that resources to the data center. Okay, so usually if you go like 10 years or 15 years before, each and every company, whatever you name it, those organizations comes up with their own data center. Okay, so now the solution architect wanted to deploy one application using plenty of the tools. For all of those tools, we need some kind of a servers, we need some kind of a resources, we need some kind of a infrastructure. That infrastructure is not available in the organization, or not available in the data center, I mean to say. And then he will try to put a request to the procurement team, and the procurement team try to connect with the vendors team, and vendors team try to move all or shift all the required hardware to be moved to the data center. Okay, so what the procurement team do, they would have ordered by a procurement team. This team will put a new request to the vendors. Now it will take days or weeks or even months for the hardware to be purchased and delivered to the data centers. Okay, sometimes it could go up to months also. Okay, once the procurement team places a request to the vendors team, it may take days or weeks, even 2 months for the hardware or infrastructure to be purchased and delivered to the data centers. Once the resources are received at the data centers, the field engineers come into the picture. The field engineers come into the picture, and they are going to take charge of rack and stack of the equipment. So whatever the resources, whatever the infrastructure they have done, right, so those infrastructure they're going to be keeping in the form of a rack and stack. Okay, you might have, I will show you rack and stack how it looks like. So the field engineers are the in charge of rack and stack of the equipment. Then system admins come into the picture, and system admins performs the initial configuration, and the network admins make sure all of these systems will be available on the network or not. Okay, what the system admins do, sir? System admins perform the initial configuration of your systems. Once the initial configuration of the systems are done, network admins come into the picture and they will try to make sure that all of these systems are available on the network. Okay, then the storage admins take the charge, and the storage admin assign the storage to all the servers, and backup admins configure the backups. Finally, once the system have been set up as per the standards, they can be handed over to the application team. Okay, this application team is the one is working based on the solution architecture. Whatever the solution architecture, he prepared the architect, right? So based on that, application team will deploy their application on top of these infrastructure, which was done by these field engineers, system admins, network admins, storage admins, backup admins, whatever who are, they build all of these systems and they made available over the network. They configured the servers, they configure the backups, and finally application team take up all of those infrastructure and they deploy their application on top of their infrastructure. So that is what it is. Okay, so this is how a typical organization used to work earlier. So this is how a typical architecture of a company. So as soon as there is a requirement from the business, a business analyst will gather the information and pass on the technical information to the solution architect. Solution architects design architecture to be followed for the deployment of the application. And if he has all the resources readily available, he will try to go with the application. Application team directly deploy the application top of the infrastructure, but most of the times that infrastructure may not be available in the data center. So that's where the solution architect will create a request to the procurement team, and procurement team connect with the order vendors team, and vendors team take days or months or even for some other days to deliver all to purchase and deliver all the hardware required for the this particular thing. And once that is there in the data center, field engineers come into the picture and they will take charge of the rack and stack, and system admins will configure the systems, network admin configure the systems to be available over the network, storage admins assign the storage, backup admins configure the backups. Okay, so that's how finally the application team will be deploying their application on top of the data center or on top of the infrastructure that is there in the data center. Okay, so what is the problem here, sir? So far so good. What is the problem here? And if you see, the turnover time varies from weeks to months to be everything ready for the application deployment. You see here, as soon as the businesses came and the solution architect deployed the solution architect prepared the architecture, the application team follows the architecture. They might have prepared their code, but they need to be on hold until the entire infrastructure to be readily available. It could go up to weeks to months, so that everything will be ready. Then only application team will be deploying the application. So the turnover time or the slow deployment, you can say, okay, the turnover time varies from weeks to months to everything ready for the application deployment. So that's the reason I'm saying it is a slow deployment. The model of the deployment is slow. And the next thing is that the overall cost to deploy and maintain this model is generally high, because there are plenty of the people needed on this system, and all the infrastructure we need to be manually purchasing and manually delivering it to the data center. So the overall cost to deploy and maintain this model is very, very high. Okay, and one more thing is that limited automation. While some of the aspect of the infrastructure can be automated, but several steps such as rack and stack, other deployment procedures are manual. So that is the reason the automation is mostly slow or very limited. Okay, so that is what I'm saying. Some of the aspects can be easily automated, but if you could see, most of the things are done manually with the help of the human. So that is the reason we cannot be able to automate some of the process. Like you can think of like a rack and stack or stack cabling. You can think of like cabling cannot be automated, right? So that's how the limited automation. And one more thing is, due to the many people involved or with so many teams working on so many different tasks, chances of human error are very high. Okay, the chances of human error is very high, so it could lead to inconsistent environment. It could lead to inconsistent environment. And another major disadvantage is that waste of resources. Okay, what is mean by waste of resources? That so you buy the plenty of infrastructure, but you may not be using those infrastructure to the 100%. It is called as a underutilization of compute resources. Okay, so these are all the problems. Due to these many disadvantages over the past decades, organizations don't want it to follow this working model. This working model is also called as the on-premises working model, because the deployment is slow, the process is highly cost, and the automation is limited. There is a prone to human error, and the environment may become inconsistent, and the underutilization of compute resources. So with all of these things, the working model is not that much benefit to the organization, because due to these disadvantages. So that's where the organizations were looking for different solutions. Okay, and one of that solution is, or one of that aspect who provides you the benefits is cloud providers. That's where the cloud provider came into the picture. And most of the organizations now looking towards the cloud providers, because you don't need to manage this entire infrastructure, like from the data center, field engineers, system configuration, storage admins, backup admins. This concept is now not there for most of the requirement of the business. You don't need to do the stack rack and stack cabling. You don't need to do the system configuration or a network admin network assignment, or you don't need to go for the storage assignment, or you don't need to go for the backup. This all of these manual things are taken care by the cloud provider. And what they do is that the best thing about the cloud provider is that they're going to provide you the three varieties of that services, like virtual machine based services, or fully managed services, or a serverless services. So you select the requirement as per you, and you don't need to buy the infrastructure. You don't need to deliver that to the data center. Everything will be available over the cloud. You can just go to the cloud and just configure the infrastructure. It will be available in next to 5 minutes. Now we don't need to wait for months or weeks, days, months. We don't need to wait. Just to configure it, next to 10 minutes, everything will be available in front of you. So that is the reason cloud becomes very famous. So most of the organizations wanted to take the advantages of the services provided by the major cloud providers, such as AWS, Google Cloud Platform, and Azure. Okay, so what is the advantage, sir? If I have to say, the advantage is that the deployment model is not slow now, because you don't need there are no manual intervention is required here. Due to that, once the solution architect prepares the architecture, the application team can just spin up the infrastructure required for that, and they can able to deploy their application. So the deployment is very fast now. Comparatively deployment is very fast now. So that is, and the cost effective also, because we are not taking the infrastructure. Because what happens is that in the on premises, you buy it, you purchase it, you move it to your data center. All of those things actually makes a cost, and you manage your field engineers, And one more thing is that you provide the 24/7 electricity for the data center, 24/7 cooling supply to your data center. So it was very costly at that time. But now you just manage the infrastructure, whatever the amount of infrastructure you need it, you only configure that much of infrastructure for your requirement. Okay, so that is the reason cost effective compared to the on-premises model. And so mostly cloud providers are comes up with the APIs. Because of that API, application programming interfaces, everything works. So whatever the service that you are working, it is behind there is a API. So whenever you are working with the APIs, API calls, the automation is very high. You can able to connect it to one more system easily. You can able to integrate multiple systems easily. So that is the reason the automation is very high comparatively. And as I was telling you, to build the infrastructure, we don't need the field engineers, we don't need system admins separately, we don't need the storage admins separately, we don't need the backup admins. Directly solution architect, as soon as the solution architect designs the architecture, the application team follows it and deploy the application. So the human intervention was very less. That is the reason the prone to the human error was also less. When there is no human error, the inconsistency of the system will also go away. And finally, we we only configure the infrastructure that we need. We don't configure the extra, we don't configure the less. And one more advantage with the cloud providers is that there is a auto scaling according to your requirement, according to the requirement of infrastructure from you. The infrastructure can scale up or down as per your requirement. So if you need today some amount of 100 GB resources, tomorrow it is 200, day after tomorrow it is 100 again. So you don't need to manually sit there and making it up, making it down. Automatically it will be scale up and down as per your requirement. So that is the reason you don't need to put high infrastructure requirement, you don't need to make it down. Okay, so that is the reason the wasted resources, the underutilization of the resources is also not in the pot. There is some amount, but comparatively, we are not going to waste the resources that much in the on-premises. So again, the benefit is we do not need to worry about the wasted of resources in the cloud. So these are the advantages that the when you compare your on-premises working model with the cloud. Okay, so in an on-premises working model, you were facing with the slow deployment, high cost model, and human errors are there, inconsistency in the system, automation was limited, and wasted of resources. But when you are working in the cloud, comparatively the cost is less, automation is high, as well as the human errors will not be there because no many humans are in not required for the infrastructure building, and the wasted of resources is also not that much. Okay, so this is the reason most of the companies are looking towards the cloud platforms, and they are taking the benefits of the cloud computing services provided by those cloud providers. Okay, so in one word, if I have to say the difference between the on-premises working model as well as cloud computing. Okay, in on-premises working model, an organization managing its own infrastructure to run their codes or applications. What is mean by infrastructure? I've been telling infrastructure all the time. The infrastructure means it could be a servers, hardware, software, networking components, or storage components. Okay, these are all the physical ones. So when you need a server or a hardware or a software or a networking or a storage, you can also call it the virtual machines. Also, you can also call it a Kubernetes or containers also. All these I'm calling as the infrastructure only. So if an organization is there, if it's managing its own infrastructure to run their application or to fulfill their business requirement, then that kind of a organization I'm calling as it is following a on-premises working model. If an organization is benefiting the services provided by the cloud computing, then that are cloud provider, then that kind of a company we are calling as a cloud computing working model. Okay, cloud working model. So cloud provider delivers the infrastructure as a service. The organization take benefits of those services. Okay, and we only pay for whatever we use. So this is the difference between the on-premises and cloud computing. In on-premises, we manage everything on our own. In cloud provider will provide you the services. You take the benefit of those services. Okay, so this is what is the on-premises versus cloud. And in on-premises versus cloud, if you still wanted to understand this, this chart actually gives you a very good understanding related to it. Just pay attention to me for next 5 minutes. Okay, so here if you can see clearly, when you are working in on-premises, you have to buy your or you have to purchase your physical infrastructure. You have to deliver it to your data center, and you have to manage. If you need a virtual machines, you have to manage your virtual machines. You have to manage your application service. You have to take care of your development. Okay, so physical infrastructure you have to take care, and virtual machines also you have to take care, and application, the platform for your application you have to install and take care of it, and finally on top of your application service you have to develop your solution for your users. So in on-premises, if you think that you are focusing on 4 main points here, but when you go to the cloud, you have 3 options. Cloud provides you 3 variety of services to you. One is VM based services. One more is managed services. The third one is serverless services. So VM based services, managed services, serverless services. What is mean by that, sir? Sir, if you go to the VM based services in the cloud, you don't need to buy the physical infrastructure. You don't need to purchase it and maintain the physical infrastructure. That will be taken care by the cloud provider. Okay, that will be taken care by the cloud provider. And when you are, if you wanted to take care of virtual machines, you have to manage it. Application server, you have to manage it. Developing the solution, you have to manage it. In VM based services, the advantage that you get is that you don't need to purchase the physical infrastructure. You don't need to manage the physical infrastructure. And when you go to the managed services, no need of purchasing the infrastructure or managing the physical infrastructure. No need of managing the virtual machines. You can just focus on the developing your solution and application service. When you go to the serverless services, no need of physical infrastructure management, virtual machine management, no need to do. Application platform also, we don't need to worry about it. We can just directly focus on the developing your solution as per your business requirement. As per the business requirement, you can just focus on your developing the solution. All the infra related activities will be taken care by the cloud provider itself. Okay, all the infrastructure required for the business, fulfilling your business requirement, will be taken care by the cloud provider itself. So that is the difference between the on-premises versus cloud. In on-premises, you are focusing on all the things. Your organization has to manage all the things. In VM based, just 1 minute, guys. It's a lot of disturbance. 1 minute, please. Yes, sorry. So in on-premises, you as a company, you as a project, you as an organization has to manage everything on your own. But when you go to the cloud, cloud provides you three categories of services to you. First category is VM based services. The next category managed services. The third category is serverless services. When you go to the VM based services, a physical infrastructure we need not to manage. When you go to the managed physical infrastructure plus virtual infra, we need not to manage. So whenever you say when I say in infrastructure, there are two types. Okay, when I say infrastructure, there are two types. One is physical infrastructure, one more is virtual infrastructure. Okay, physical resources are virtual resources. Okay, so that's what it is. This is a physical resources, this is a virtual resources. Okay, and yeah, when you go to the serverless, you don't need to worry about managing the physical infra, virtual machines, application service. You can just directly focus on your development. So that's what the cloud providers say, is that you don't need to, as a data engineer, you don't need to worry about the infrastructure. We will take care of the infrastructure. Just focus on the development and just focus on the data analysis. Just focus on the data insights, which will be very useful for the business. All the infrastructure requirements will be taken care by the cloud provider. So the green ones here, you as a developer don't need to do it. Google manages it for you. And as a orange color, if you, based on the model that you selected, you as a developer need to do it. Okay, so this is what is the difference between the on-premises versus cloud. And still, sir, I wanted to look at as an example, so let's take a practical example and try to understand. Okay, so this is one of the requirement from your client. Think like that. So as a GCP data engineer, you are requested to store and process a CSV data. What's that? You need to store the data and you need to process the CSV data. Okay, the size of the data is 1 TB, and end user wants to access it in a table or format using the SQL. Okay, so what is this one, sir? You are requested to, first we need to store the data of CSV, and after that we need to convert that CSV data into tabular format, and he wanted to access it via SQL. That means that platform, whatever you are selecting, right, it should be able to come up with a built-in query engine of SQL. Okay, and we are processing almost size of 1 TB. Okay, so how do you solve the request? I'm gonna give a 1 minute for you guys to think about it. So think about all the possible ways of practically implementing this situation. Right. I guess some people might have thought about it. Some people couldn't able to think much, or some people might have come up with some solutions. But let us see the possible ways. Before I am going to the cloud, I'm going to think about it, how I'll be doing it in the on-premises. If it is an on-premises working model, how I am going to do it is that first I need to buy a cluster of machines, and I need to make sure that I need to manage my virtual machines, and I need to create a cluster of it. Okay, I need to manage my VMs. That means multiple machines. Once the multiple machines, I bought it, and after that I make a cluster of it. On top of my cluster, I will install Hadoop. On top of Hadoop, I will store the entire data in the HDFS. On HDFS, on top of HDFS, I will install Hive. So first I will be storing the data here. 1 TB of the data, I will be storing it here. And on top of Hive, I will be able to retrieve the data using SQL. Okay, so this is what I have 4 steps here. Okay, so first I will take care of my I will manage my own virtual machines because I need to create a cluster manually. After that, I need to install the Hadoop and HDFS and Hive so that I'll be able to convert that CSV data from HDFS to the Hive as a table, and I can able to retrieve the data using SQL. So this is one of the possible solution, but here we are managing everything. So this is the reason I'm calling this as a on-premises working model. In on-prem, I am following this model, sir. In on-premises model, I am following this one. But what is the cloud doing it for you? Let's think about it. What is the cloud doing it for us? So when you go to the cloud, as we seen, we have three types of services. One of the first type is VM based. One more is managed services. The third one is serverless. Let us look at VM based. Okay, so if you go to on-premises, you are managing your you have to buy your machines, and you have to manage your entire virtual machines. Okay, but here the very first step that you are doing in two steps, that is converted into first step, that is you can directly provision the multiple virtual machines in the GCP using Compute Engine. In GCP, if you go in GCP, we have a Compute Engine. You can able to create a virtual machines and install the Hadoop cluster on top of your virtual machine and store the data in HDFS, and you can able to create a Hive table from the Hadoop cluster. Okay, what is the step that the on-premises that we have omitted here, and that we have got a benefit from here, is that you have to manually buy your machines, or at least you have to pay the cost to your machines because you are using it. But here you need not to purchase anything because all the things are readily available in the cloud, and you need not to do that cabling, you need not to do that networking, you need not to do that all of those things you need not to, because whatever the systems you buy, you need to do the system configuration, network configuration, storage configuration, backup configuration, all of those things you have to do. And that is what I'm calling as a infra management. Those infra management is not there here. You can directly provision a virtual machines in the Compute Engine and install a Hadoop cluster on top of it. In HDFS, you can able to store the data. In a Hive, you can able to process the data using the SQL. Okay, Hive comes up with a built-in SQL query engine. You can able to add HQL, they call it as a Hive query language, HQL. You can able to retrieve the data using that HQL language. Okay, so this is how the first scenario, that is VM based. Next scenario, that is managed services. And Google actually offers you one of the service, that is Dataproc. And Dataproc, you don't need to manually provision your virtual instances. You can just create a directly cluster. You can directly go to the second step here. Okay, you can directly click on create cluster, and the cluster creates manually the cluster creates the virtual machines in the backend. You don't need to worry about manually provisioning the virtual machines. Automatically, when you create a cluster in the Dataproc, all the virtual machines will be come into the picture. And on top of that, store the data in the HDFS. Hive, you can able to store the data, and you can able to process the data using the HQL. Okay, so this is a second scenario where with the help of the managed services, we are going to process the data. We are going to achieve our requirement. The third thing is that Google provides you serverless options as well. And one of that option is BigQuery. Okay, you can able to store the data in the BigQuery table directly. If your data is from CSV or any amount of data, anything, we don't need to worry about it. BigQuery stores any amount of data. You can directly store the CSV data in the BigQuery table, and BigQuery will be, even though you give a CSV, but BigQuery stores the data in the form of a table. And BigQuery comes up with an SQL language. You can able to use the SQL and retrieve the data from the table. Okay, so this is how from on-premises you are taking care of four things, but here three, but here two, but here only one. Okay, so each and not only for all the requirements, this couldn't be the solution, but for this particular thing, to give you an idea of how actually virtual machine based services or a managed services or the serverless services actually work. So this is a very good example for you to understand the difference between the on-premises versus cloud. And cloud, in cloud, the difference between the VM-based versus managed versus serverless. Okay, so this is what is the, this is how you will be able to achieve this particular thing. Okay. So as a GCP data engineer, if you wanted to store and process the data, now you now know 4 options. If you go to on-premises, you will be able to do it like this. In cloud, you will be able to do with via 3 ways. Okay, so this is how the cloud platforms are doing benefit for us, and this is the reason cloud, most of the most of the companies or organizations moving towards the cloud, and this is the reason we need to learn the cloud. Okay, and as I told you, what is a Google Cloud Platform, sir? A Google Cloud Platform is a one of the leading cloud provider which provides you the cloud computing services in various categories. One is compute services, networking services, big data services, storage and database services, machine learning services, IAM services, management tools. These all will have 3 categories: VM based, managed, serverless. So you will be able to see all the options here: VM based, managed, and serverless. Okay, so that is what is that the cloud is doing to you, and GCP provides you the suite of cloud computing services for your organizations to build, deploy, and scale your applications on the Google's highly scalable and reliable and global infrastructure. Okay, so we will see where is that the Google infrastructure is situated, sir. Where is that Google's data center is available, sir? In India also, do we have the Google's data center? All of those things in our upcoming sessions we will see whenever we are learning about the GCP locations. Okay, so this is a GCP suite. This is what is the Google Cloud Platform. Is a suite of cloud computing services provided by the Google that offers wide range of products and services to help organizations build and deploy scale applications and services in the cloud. This is what I have told you yesterday. That's the reason I'm not repeating it, guys. It's very simply that the whatever, if you think that your organization needs some kind of a services to build, deploy, scale your applications, all of those set of services is provided by the GCP. Okay, so that is what is your cloud provider. And why we learn GCP? The next question is, sir, we have AWS, sir, we have Azure, we have GCP. So these are the 3 leading cloud providers, sir. Why only GCP, sir? Okay, the very first thing is that for the Google, the community support is very high. Okay, then comparatively, Google offers the services cost effectively. Comparatively, if you take one of the service in the GCP, sorry, for example, one service, and the cost of that service in the AWS is, the cost of that service in the Azure, the cost of that service in the GCP, if you compare, and here if it is 100 rupees, here it is some 80 rupees, here it could be only 60 rupees only. Or you can think of like here 90 and here 80. 100, 90, 80. So that's how Google provides you the services cost effectively compared to the other cloud providers. So that is the reason, if something is with the flexible, scalable, reliable, secured, and fast services, if one cloud provider provides you the same benefits of all other cloud providers and gives you the cost, service cost is very less comparatively, then that's the reason organizations wanted to use those services effectively. So that is the reason nowadays most of the organizations from the startup to the mid-level to the product-based companies started using the Google Cloud Platform, and this is the reason we need to learn. Okay, not only that, it is a market leader. Google Cloud Platform is a market leader, top 3 leading cloud provider. Industry adoption is there. From the startup to the product-based companies, the industry started using the GCP. Comprehensive service portfolio. I told you, category of services, right? Comprehensive service portfolio means you have a compute options, you have a networking options, you have a big data as well as machine learning. So comprehensive service portfolio is there for the GCP, and integration and compatibility. You will be able to easily integrate with all other services in the GCP, and outside the GCP also you can able to easily integrate it. So that is the reason. One more thing, and Google provides you the machine learning capabilities as well. Google have an extensive global network throughout the world. Okay, Google has an extensive network throughout the global. I mean to say that data centers are available throughout the world. Even in India also we have. And this is one more thing that we need to look at is that. So we are coming from on-prem. We are actually coming from on-prem. So this is how we moved, right? The technology advancement on-prem to the cloud. And the next era is that multi-cloud. Already some of the companies are already started working in the multi-cloud projects. Okay, so we now know there is a benefit of using the on-premises to the cloud, but cloud to the multi-cloud is one more next universe. What is this one, sir? If I have to say like this, AWS is very famous for ML, machine learning services. Azure, this is from the experience we are talking, guys. This is from the community experience. Azure very famous for CI/CD. GCP is very famous for big data. Okay, big data, very famous for big data. So earlier, the current trend is that if you are working in one project, all the services in the project are related to the AWS or Azure or GCP. All the services. For example, if you are talking about one project, that project using some 6 services, all those 6 services from one cloud only. That is nothing but a cloud platform. But if you go tomorrow, maybe if you look towards the future in the next 3-4 years, you will be able to see the multi-cloud projects. That means 2 of the services from the AWS, 2 of the services from the Azure, 2 of the services from the Google Cloud Platform. So this is also the one must reason that we must focus on the GCP big data. Okay, we are going to learn those big GCP big data skills in our topic. Our most entire course is GCP big data only. Data engineering with the Google Cloud Platform, nothing but a big data only. Okay, so this is our future. You will be able to see in next 2 or 3 years. Multi-cloud era. So on-prem to cloud era, cloud to the multi-cloud era going to be already started. Some people are already using it, and it could take some time. In next 2 or 3 years, most of the projects will be multi-cloud only. And Google provides you the certification and career growth as well. Whoever has certified in the Google Cloud Platform, the hike or the advantages that they get is far better than any other. So that's the reason. These are the reasons that we need to learn the Google Cloud Platform, sir. A market leader, industry adaptation will be there, comprehensive service portfolio, integration and compatibility, machine learning capabilities, global infrastructure, multi-cloud projects, certification and career growth. And if you still wanted to see the growth rate, you see here the growth rates. The last quarter, the growth rate for the AWS was only 32% and Azure is 51%. The GCP is here 54%. Why? What is mean by growth rates? Growth rates are the company adaptation is nothing but a growth rate. Company adaptation means projects are moving to the Google GCP, so the manpower required for the GCP is very high. So that's where most of the companies are looking towards a Google Cloud Platform. So that's the reason the growth rate is high compared to the all other clouds. So that's the reason we need to have a proper manpower. For that reason, most of the people are started already learning the GCP, but still some people does not know what is GCP at all. Okay, so this is a very good choice. There are plenty of opportunities. I'll be very honest on this point. There are plenty of opportunities on this one. You can leverage those. Okay, so Google's GCP roles offered with this course, GCP data engineer, you can go, GCP developer, you can go, GCP admin, you can go. Certifications, Associate Cloud Engineer certification, you can able to achieve it with the help of this course. Professional Data Engineer certification also you can able to achieve. Okay, yeah. Now I'm going to stop it here for today. And if you guys have any questions, you can talk. Tomorrow's our topic is how to interact with the GCP. And we have these many services. If I wanted to interact with the GCP, we have console, Cloud Shell, APIs and libraries, web applications. We are going to see one by one. Okay. So what is actually this console? What is a Cloud Shell? And everyone we are going to learn one by one. So I'm going to stop it here for today. So if anyone have any questions, you can put it in the chat, or you can unmute yourself and talk, or raise your hand. I will call you.
Sheikh, in this course content, you cover data developer like to create new services and consume those services through any programming languages, is right?
So I did not get your point. Sorry.
So
Sorry?
I'm expecting GCP developer.
Okay.
So I want to create a new services like a blob storage buckets like that. So can I create those services and then can I consume in different?
Correct. That's what we are doing. As a data related activities, whatever you are going to do, I wanted to create a file, I wanted to do processing, I wanted to use it in some other service. Yes, of course. Yes.
Because
Any other
I'm
question?
a Azure developer, so that I want to learn a few things related to GCP.
Okay. Okay. Yeah.
Is it suitable for me?
Yes. Yes. Of course.
Yeah. Thank you.
Sure. Yeah. Anyone have any other questions, guys? So we have like 3 to 4 minutes before we wind up the session. If anyone have any questions, it's a good time for you to open up. Upstream or downstream means the source team, the team that you are dependent on. Downstream means there is a team that there's a team that is below you that who expects something from you. Okay, upstream means the source team, downstream means the destination team. You can think of like that. Yep, I think we're good. Okay, guys, thank you all. We will wind up the session here for today, and we're going to be talking about how to interact with the GCP. Practically, we are going to see, and we will see maybe tomorrow, and we will meet at the same time, guys. Thank you all. Have a great day.